In this video, I'm going to go through review 2 for the first part of the circles unit with all the rules. A reminder that you can use your study sheet for tomorrow's quiz. Number 1, in the following diagram, which of the following is not an example of an inscribed angle of circle O? Well, remember, if I have a circle, an inscribed angle has a vertex on the edge of the circle, and its rays intersect the circle, something like that, right? And if I look at answer choice 1, angle NST, notice that the ray ST doesn't end on the edge of the circle, so that opens up outside the circle. That would not be an inscribed angle. But if I look at MNS right there, or SNT right there, or NSM right there, notice all those have vertexes on the circle, and their rays intersect the edge of the circle as well, so those are all inscribed. Number 2, in circle M below, AB is parallel to radius MC, so I'm going to mark that, and diameter AD is drawn. If the measure of angle DAB is 52 degrees, then which of the following is the measure of arc CD? There's a lot of different ways you can do this. The first thing I notice is that angle DAB and angle AMC are congruent alternate interior angles between those parallel lines, so that would mean that AMC is also 52 degrees. Which means if I double that, if I just mark angle AC there, I could say that arc is 52 degrees as well, because remember, that's a central angle. It has a vertex at the center, and a central angle is equal to the arc it intercepts. Now, the last thing I notice is that arc AD should be 180 degrees altogether, because they told me that I've got this diameter AMD there. So if I subtract 52 from 180 to find the missing piece, my missing arc for CD is 128 degrees. Number 3, in circle K, chord CD bisects AB at E. So that means that AE and EB must be congruent to one another. If CE equals 4, ED equals 16, which of the following is the length of AB? The first thing I could do is I could label both my parts AE and EB as X, because I know that chord is being bisected, and I know that this is two chords intersecting in a circle. So because of the similar triangles proof, I could do part times part equals part times part. 4 times 16 is 64. X times X is X squared, and if I take a square root, I find that X equals 8. Which is an answer choice, but notice that I'm looking for the entire length of chord AB, which is just X plus X, or double that, 16. Number 4, if points A, B, and C lie on circle E, then which of the following does not have to be true? Well, it says circle E, so there's center E, and A, B, and C are somewhere on the circle. So that's all it tells me. So I'll put them wherever I want. So let's go through these. Is it the case that the measure of arc AB plus the measure of arc BC is equal to ABC? Well, yeah, if I sum those two together, that gets me all the way from A to C. Is the measure of arc AB equal to 360 minus BCA? Well, yeah, that's a major and a minor arc, so those should sum to 360 degrees. And if I add arc AB plus BC plus CA, notice that gets me all the way around a circle, so it should be equal to 360 degrees. But there's nothing here that would suggest that AC, this arc right here, and BC need to be the same measure. I could have put angle or point A and B anywhere else. Think about if I put point A all the way down here, then AC is way smaller than AB, so those are not necessarily the same length. Number 5, points A, B, and C lie on circle M such that the measure of arc ABC is 262 degrees. Which of the following below is the measure of angle ABC? Well, they gave me this major arc ABC, and if I subtract from 360, I could find that the measure of arc AC is 98 degrees, and ABC is just an inscribed angle. And remember, an inscribed angle is half the measure of the arc it intercepts, so that angle must be 49 degrees. Number 6. Points E, F, G, and H lie on circle O such that the measure of angle FEH is 65 degrees. And the measure of GFE is 80 degrees. Then which of the following is the measure of angle FGH? Well, this is a quadrilateral inscribed in a circle, so remember that opposite angles are supplementary. So if I just subtract 65 from 180, I find that the missing angle is 115 degrees. If I needed angle H, I could just look at the 80 degrees opposite from it and find that's 100 degrees. Number 7. In semicircle C shown below, the measure of arc DE, I'll mark that at the top right there, is 104 degrees. If DE is parallel to diameter AB, then which of the following is the measure of angle BDE? Right in there. Well, it would help if I had chord EB, then I could just subtract from 180 because D is an inscribed angle. But they tell me that the chords are parallel. And remember that parallel chords intercept congruent arcs. So I don't know what the measure of arc EB is, nor do I know what the measure of arc DA is, but I know that they're the same. And I know that this is a semicircle, so rather than those arcs summing to 360, I can sum them to 180 degrees. So I can do 104 plus x, which is just plus 2x, equals 180 degrees. If I solve this two-step equation by subtracting the 104 over, I get 2x equals 76. And when I divide out the 2, I find that x is equal to 38 degrees. So that's the measure of the arc. And to get the inscribed angle, I could just take half of that, and half of 38 is 19. Number 8. In circle M, diameter QS intersects RT at W. If the measure of arc RS is 131 degrees, and ST, right there, is 21 degrees, then which of the following is the measure of angle RWQ? Well, remember for an inside angle formed by two intersecting chords, I can just add the two arcs they intercept and divide it by 2. So that would be arc RQ on arc ST. So the angle X equals 21 plus, well, I need to figure out what arc QR is right there. And they tell me that I've got a diameter QMS. So that means that the blue arc over here and the pink arc should sum to 180 degrees. So if I subtract from 180, the missing piece should be 49 degrees for RQ. So 21 plus 49 divided by 2. And 70 divided by 2 is just 35 degrees. Number 9. In circle L, the measure of arc AB to the measure of arc BC to the measure of arc CA is 2 to 2 to 1. So I could label BA as 2x, BC is 2x, and AC is 1x. Which of the following is the measure of angle CAE? Well, remember CAE is just a tangent and a chord, which is half the arc it intercepts. Now, I don't know what the measure of that arc is yet, but I know if I sum up all those arcs, I make it all the way around a circle. So those three arcs, as I've labeled them, should sum to 360 degrees. So if I solve that equation, 5x equals 360, divide out the 5, I find that x is equal to 72 degrees, which means that this arc is 72 degrees, BC would be 2 times 72, and BA would be 2 times 72, but I really only care about arc AC here. Remember, for a tangent and a chord, that's going to be half the arc it intercepts. So if I take 72 divided by 2, that angle down there is 36 degrees. Number 10, in circle L, PB is tangent to the circle at B. The measure of arc AC is 130 degrees, and the measure of arc AB is 62 degrees, right down there. Now, with this information, before I even do anything else, I know I'm looking for angle P. And the outside angle here is going to be equal to the big arc minus the small arc over 2 because it's a tangent and a secant. That's always the case for an outside angle. But I've already have 130 and 62 degrees accounted for. So if I subtract from 360 to find the measure of arc BC, the big arc I need here, I'm going to find that that's just 168 degrees. So the big arc that I'm going to subtract is 168 degrees. So I'm going to do 168 minus 62 over 2. And I get 53 degrees there when I simplify. Number 11. Encircle O secant QT intersects O at Q such that QS is 4. If the length of the tangent QR is 8, determine the length of QT. Well, remember for two secants, it would be outside times hole equals outside times hole, but when I have a tangent line, the outside and the hole are the same length, so I could just rewrite that as tangent squared equals my outside part times the hole. So that's my tangent length is 8. Remember, a tangent only intersects a circle once. Equals my outside piece, QS is 4, times my whole length. That's what I'm looking for. That's QT. So 8 squared is 64. And to undo that 4, I can divide it out to find that the length of QT is just x equals 16. Now they want the length of the radius. So that's going to be either from O to T or from O to S. Those are the same length. Well, I can figure out the length of the diameter, right? If the whole thing is 16, and I know the outside piece is 4, 16 minus 4 is just 12. So the distance from S to T is 12. That's the diameter. If I know the diameter is 12, to find the radius, I can just cut that in half. So my radius is 6. Number 12. Isosceles triangle EFG is shown below, inscribed in circle O. The measure of angle GEF is 34 degrees. Find the measure of arc EHG. Alright, so this is an isosceles triangle. So I know that base angle down there is 34. So 34 plus 34 is 68 degrees. Which means if I want to find angle F or angle EFG down there, the interior angles for a triangle should sum to 180. So my missing angle is 112 degrees there. But that's an inscribed angle. And remember, that's going to be half the measure of the arc it intercepts. And if I'm just looking at that 112 right there, that intercepts the arc that I'm looking for, EHG. So I could just take that 112, double it, and that finds me the measure of arc EHG is going to be 224 degrees.